Hey guys, this will be video 6 for the how to design build a 58 Explorer replica, and sometimes using the Stuart McDonald templates, and like right now I'm going to talk about that a little bit, but obviously this is a fairly unique guitar because it's going to have P90s and it's a Goldtop and it's got binding in the body, and we have binding up the fretboard like a Les Paul, but no binding at the headstock. So it's kind of like based on I say it's influenced by the 56 Goldtop. It's a flat top guitar. I've already talked about that enough. But with that said, what I'm going to do in this video is just talk a little bit about just fitment, and picking up from video 5. Where was I? Okay, since video 5, I have since tapered the profile up to about 99%, within about 99% of the actual finished guitar. And when I say close, extremely close, that's pretty much the guitar right there once it gets rounded over, but it'll get about a 32nd of an inch taken off of this side. But again, all this was done just working from the center line. And the cool thing is I did get it fit perfectly, and I got a really beautiful joint around all the visible, because it's not a paint grade guitar, and when they're clear, it's got to be right. It's got to be perfect. It's got to look like it came from who. And I don't necessarily mean just Gibson, Gretsch, Fender. There's a ton of quality manufacturers out there. It's got to look like it was built by someone that knew what they were doing, or either by a machine that knew what it was doing or was programmed to do it properly. So it's all handmade, and in other words, it should be fine. Okay, so let's talk about the most important thing we need to do before we start talking about using router bits in order to speed up the build of the process. And you can't do that work until you've tapered it. So the operations are typically, it's S4S per video 5. It's S4S. You get the heel cut, start doing the initial fit work. Anything that's not working, make changes on the tenon and the heel. Don't start working with both, because that one's true over there. But what is important now is making certain that you move to the point to where you start really double checking that the next thing is to make certain that you've really hit your target right here. Well, every bit of it has to hit perfectly, but I did. I'm perfectly true right there. I'm where I want to be. But then I actually have the guitar that I want, and I had to go ahead and glue this block on there because I'm getting ready to start doing this route work, and I hate that because this is like, honest to God, I think this is the 5th time I've done this video. And the last video, there's a part of me I wish I hadn't erased it and started over, because I spent a lot of time talking about things that would have been so beneficial, but it was just getting ridiculously detailed. And you'll see it after the guitar is built. I've got a beautiful fitment across the bottom. In other words, I'm not using that just to hide anything. It's really beautiful down there. And it's pretty much a finished guitar, or very close. But nonetheless, once you have it fit, where you want it, now the next thing you got to do is verify your taper. And you should have already done this before you started doing any of the taper work on the neck. But nonetheless, all you got to really do is just pull a straight edge up here to the where the bridge location is going to be. And I made a mark. See, that's 5/16 of an inch high. What this bottom edge here represents is the bottom edge of the fretboard. In other words, that's the cross section you see drawn right there. The bottom edge of the fretboard, the top of the fret, but not only the top of the fret. That pencil line that you see right there represents the very bottom edge of the actual D and the G string. In other words, if your fretboard was flat with no radius, then it would be 5/16 all the way across. But we're installing all this based on the center line, or the highest point of thickness, and that's the center of the fretboard. So very simple to just clamp these two together, and then actually it's not simple because I've tried it. That's why I keep erasing this video. It's making a fool out of me on camera. But basically, you just clamp that together down there at your tenon and mortise location, and then just verify that you are in fact hitting your 19 millimeter. And what do you know? 19 millimeter. Okay, and that's just me holding it rough. But nonetheless, 18 to 19 millimeter is your target. And I've already triple checked it. It's perfect, and it's ready to be epoxied in. However, in case I forget, if you're doing a clear coat guitar, you do not want to epoxy. You don't want to epoxy this plane right here because it'll create a black line, perimeter line. So when I'm doing this glue in, I will be epoxying the tenon in, but with just minimal amount of epoxy. That you don't want any squeeze out at all. This you do not want it sloppy. But this, at the very last, as it's beginning to go together, then I will actually saturate and squeeze in some tight bond. And then when it truly goes together, right there at the last, all of this in-join glue work is done with tight bond. And that's how I always do my clear coat guitars, so that it's really beautiful as far as grain to grain, and you don't see a dark line. You'll see a transition line, but it won't be nearly as noticeable as if you did it with epoxy. Okay, so should be really beautiful. Okay, with that said, I'm just going to rock it through this video and not spend too much time trying to show you how to build this thing, because this part of the build is so complex. I could spend 45 minutes just talking about doing the headstock, or I say doing the headstock, having to redo the headstock, because everything was going great, and I mean 99% finished, absolutely perfect, right at the point where the effing router bit caught that and tore out the end. And I mean, I went through the freaking roof, because when I say it was finished, I had everything about it was just, so I had to rebuild that. But, this came from the same location. Okay, this piece right here came from this location right here. That replacement piece came from that location right there. So everything about the grain and the orientation and all that jazz was fine, but it just required that I rejig everything and take off, cut that off. Well, you can actually see the actual cut. That's the kerf. That's the thickness of the table saw blade. So it took about an extra day. So put me in a nasty mood for about 8 to 10 hours. But nonetheless, after I finally got it finished, then I was okay. And how did I finish this? Finished it on my oscillating sander. I didn't give my router bit the benefit of the doubt. I just elected. Sometimes it's best to just use a really fine jigsaw with like a scroll blade on it, and just jigsaw fairly close, and then just be patient and get over there on your oscillating sander and just work your way to the finish line. And as you can see, I didn't want to talk about this, but nonetheless, it's beautiful. Turned out perfectly. Now, was that cut with the... No, I take that back. That was the initial router cut right at the point to where then I lost it down here. So that was done with the router from the template. And then but everything from here on out was just done with the oscillating sander. And I'm a 1 3/4 inch wide nut location, which this is going to be dropping down to actually a little bit more. But you want that to be massive, or have more mass, so that you can work your way to the finish line. And it will end up being 1 23/32 wide at the nut, and it will end up being roughly 21.85 millimeter was the target Ed had given me. But I always build my necks 22 millimeter. So I'm going to be building this one 22 millimeter. And then right there at the end, just making certain that it doesn't go below 21.85 millimeter, which was what he had requested. Then up here at the 11th fret location, I made a pencil. Yeah, I did make a pencil mark. There's the 11th fret. At the 11th fret location, he had given me a dimension of 24.23. And what are the odds? I typically end up being about 24.5 at the 15th fret, or right at about 24.75 millimeter at the 11th fret. So say that to say this, we're definitely on the same page. But after it's all said and done, the guitar that I finish with will be very close to, but definitely not less than the dimensions that you gave me, Ed. And rather than having the kind of like the soft D profile that you played on Eric's SG, the 69 SG that I restored, I'll be going with the 7/8 inch radius bit, and it'll be creating more of the soft C, or a little bit rounder. But with those thinner dimensions, it's not going to feel fat at all, at all. And if anything, it's probably going to feel much closer to Eric's 1981 Gibson Tobacco CMT E2 Explorer, because and that was an actual Gibson neck, the maple neck that was the Explorer neck. And when I mic'd it out, sure enough, it mic'd out pretty much identical to these dimensions that you gave me right here. So, and when I was looking at Eric's neck, when I put the radius, when I put the two different bits up against Eric's actual 81 Gibson neck, see there's a space right there because this one's a tighter radius. But if you look at this one right here, this is identical. Well, this is an 81, so they had a 1-inch radius on the 81 all the way. I mean, it's all the way. But on the let me slow down. This is an 81 Les Paul Custom, not an 81 Explorer. Eric's 81 Explorer, authentic maple neck, had this profile right here. It was the softer C. It was more round. This is the more of the D profile. But I'm just saying that when I was holding Eric's 81 Explorer Tobacco Burst neck in hand, it mic'd out basically identical to the dimensions that you gave me. So as long as we're building your neck using the red bit, it's going to feel like a Gibson. Okay, so that said, leave that off. And then let me check the time. Yeah, 13 minutes. Feels like an hour and a half because this is like the 5th or 6th time I've done this video. I just keep getting way too long-winded. I guess because it's just that I want to share every little nuance and detail, and it's probably good information for some people, but I noticed that the bulk of the people that watch my videos, they check out after about 10 to 15 minutes. They just can't really take that much information. So for those of you guys who truly stick around and watch the whole video, I really appreciate that. Not that it matters. I don't care. I'm not monetized or anything. And I'm primarily just doing these videos for the handful of guys out there that truly want to build a guitar, or either primarily the clients that I'm building the guitars for. So after a little bit of trial and error and my ego in check, got a beautiful headstock, very close to finished. It will be getting an additional veneer on the top. So, because right now when I'm looking at that, it's like, oh, it looks thin right there. Well, it's amazing, but once it gets the additional material right here, and then because see, this still has not been tapered yet, but it'll be about 9/16 of an inch thickness out here, and ever so slightly under 5/8 of an inch right here. And what is that? Well, it's identical to Eric's 81 Explorer, which was cool to have that guitar in-house, because I was able to truly verify that, yeah, I was right. They do taper that. It's not just 9/16 of an inch thick out here and 9/16 of an inch thick back here. It actually gets a little bit thicker back here because it's having a transition into the neck. Okay. Okay, and what is this block of wood right here? It is a sacrificial guide block that guides the bearing off of the workpiece, so that you guarantee that if this were the bottom of your finished neck, it just guarantees that you don't slip and take off material that you cannot risk losing. So it ends up becoming just more of a guide. It's not really sacrificial as much as it's just a bearing guide. Once you finally get to the center, because if you're up here and you slipped off, well then you're going to be cutting all that mass out anyway. But once you get down to this center line here, you want to have some sort of control. And then the way I've got my jig set up, I just guarantee that I have a stop point for the whole operation, so I don't go risk going in and hitting that. So it's very easy to do the bottom, the treble side, because you can go, see that's the beginning of the pitch. If I'm not mistaken, I usually don't chance it because I'm so terrified that I'm going to get into the headstock further than I want to. Because once I'm down pretty low, I'm just scared that I'll end up doing a scoop right there. So I usually stop about right here, and then I blend all the rest of that. Excuse me, I blend every bit of that by hand. And the same thing goes at the heel. You can't. There's no way that you could really machine a pitched headstock and a heel that has an actual heel to it like this product. The only way you could machine overhead like that is if you're building, like your traditional bolt-on neck. But then then even the headstock would have to remain flat, even though it might be offset. So you'd be fine if you were routing that neck right there. Then you stopped at a certain point, and then maybe shape that accordingly. But or either. See, that would be your overhead configuration. If I can get it to stand up. I'm not sure how I got it to stand up. That would be your overhead configuration. And then this would be your tabletop operation, where you would be machining like this, where you've got the actual template, the routing template. Well, what do you know? You got a routing template up atop that, and then a table that's flat. And that's a pretty simple build. And you're always working off you're doing cutting. You're allowing the bit, which is turning counterclockwise when you're looking at it from the top. You're always working off the left side of the bearing. But if you're doing overhead type, it's turning this way. So you would want to be cutting into it like this. And now you see why I can't do that with this type, because I would have to stop way back here and do an enormous amount of heel work. And I probably would work fairly well up here because you could really keep an eye on it. But I like my configuration where I'm routing it from this side right here, and I can actually come off of that. And this started from the fact where I used to always build the thick body jazz guitars, and the heel was even taller than what you see right there. So I was really trying to expedite the whole pre-machining of a heel for a thick, like a 3-inch thick jazz guitar. And that heel was enormous after it was all said and done. So I wanted to be able to machine as much of that off as possible. So this is the bit we'll be using for your job, Ed. And I wasn't planning on talking about that, but I think it's some good information, so I'll leave it in and try to get this thing finished as well. So I'm not certain. I think I talked about it, but that's definitely going to get the maple veneer epoxy down as well. So it'll end up being a solid wood headstock as well. There won't be any fiberboard up there or any sort of artificial material, because whatever thickness you come in with that pressed fibron or whatever it's called, a Vulcan fiber, I think they call it fibron, but if you come in with that press board material that has some sort of logo in it, then you have to machine off whatever thickness material you put up here, Well, you have to machine off, and I don't want to machine off an eighth of an inch of mahogany and mahogany just to have a piece of paper up there that has a logo in it. Not that I would do that anyway, but their builds are a little bit weaker because of that material. So you get better tone out of a solid wood headstock. Okay, I gotta reel myself back in because I'm gonna start talking. I'm gonna start going sideways again. Uh, I hope I didn't already cover this, and I don't think there's any way it's only been 20 minutes because I think I came right out of the gate talking about the headstock profile is shaped, ready to go. This thing is obviously has been tapered, and this is not how I did it, but basically it's very close to how I did it. See, I couldn't use this one because it's for a Les Paul. It stops at the 16th fret, so I've got a different type of acrylic jig where I actually did cut this one with on the router table. So if there was a bit in there, the bit was obviously sticking up like that, and but it had the bearing on the bottom. And then is that right? Is that how I did it? I can't remember. Yeah, that's exactly right. And then the yeah, it is. So the bearing was on the bottom, and then the router bit was sticking up really high, and then I cut it like that. So in other words, you have to have this taper achieved before you can start doing your profile work. It's kind of a given, but sometimes there's things like that people don't know. Excuse me. So tapering jig works really well as long as your tapering jig is long enough, and then and this one was not, but it's the same principle. Masking tape, CA glue it down temporarily, and then machine it out. Okay, after, I don't know, maybe I had already done this. I can't remember if I did this before I tapered it. I think I might have. But after I got it fit perfectly in there, and I may have clarified that block is not there to hide poor join line. It's just that I've done this video so many times, I was getting ready to do the profile shaping, and then I changed my mind. But it's a beautiful fit as far as into the body, and it's actually ready to be epoxied in. Or you could glue it in with a Titebond. And with that said, what I was shooting for is verifying the center line, which I've already covered, and I'm true. Center line of my neck is truly on the center line of my body, which is defined by the glue up join from the two pieces of maple. But the next thing is you're then verifying your pitch, your neck to body pitch, and you've already done this in the past before you did any of this nice work, but your target is I've already clarified 18 to 19 millimeter at the two middle saddles, the D and the G, and that's from the top of the guitar to the bottom edge of the string. You want it to be about 18 millimeter finished out because you're going to have a fretboard thickness on here. But if you did not have a fretboard, a pickguard, you're going to have a pickguard. But if you're not going to have a pickguard, you might want your string height at the D and the G to finish out at about 17 millimeter. I think I've already covered this in this video series, but I'll just recap it. But how you achieve that is by engineering all this on the front end, whether you're using the 2.5 degree pitch or a 3 degree pitch or you're not going to be more than 3, but if you were a 2 degree pitch, which is flatter, then you're going to need to come out of the body more. You can't go all the way down in the body. I'm going to stop creating hypotheticals. But if you were pitched 3 degrees, you might want this to go, you probably would need this to go in the body a little bit deeper. But then when you looked at it from the side, your, it's so hard to do, your your binding would get clipped on the corner right there, and it would be really unsightly. So with this one right here, our fretboard, I can't do everything, but your fretboard's going to kiss right at that corner right there, which I clarified in video 5. I think it's video 5. Okay, so back to basics. I'll just do it. I'll just put the clamp on it. I'll see if I can explain it without making a fool of myself. Okay, you're just trying to make certain that you're in the correct location right there. In other words, if the neck was glued in or epoxied in, and that epoxy was drying, and the question is, are you guaranteed that once you glue your fretboard down to the top of that surface that is pitched, where's the bridge going to end up, or I should say, where is the bridge going to end up based on where the bottom edge of the D and the G string are, and it's based on that line right there. Why? Because we're going to come over here. I should be able to do this on camera. Just barely under 19 millimeter. So once, and what does that mean? Well, that's my target with a guitar with a pick guard. 19 millimeter will yield a guitar that feels identical to a Gibson Explorer. Okay, that's all I can say. Or either a 58 Explorer is going to. The 58 might be a little bit different. I think they might have. I think they screwed up some of their pitches. They had some, because I saw a Flying V once, like a 58 Flying V, where man, the bridge was buried down into the body almost. It was really screwed up. It's almost. It might have been someone had removed the neck in that Flying V and they screwed it up when they put it back together. Because Gibson had already been building archtop guitars were, I can assure you, if there was any manufacturing out there that knew how to yield the appropriate bridge height, it's going to be Gretsch Gibson, period, because they were already building archtop guitars and they understood that whole calculation right there. But once you transfer to this flat top design, it might have thrown some of them for a little bit of a loop on the very first year, but nonetheless, that pitch yields the 19 millimeter, 18 millimeter. It'll actually end up being under 19 millimeter once I cut the strings into the saddles. But we're really splitting strings right now. Okay, but it's going to feel incredible. It's going to play incredible. And the cool thing is I've gotten this down to a science now where every flat top guitar that I build with a mortise and tenon neck feels incredible, and I always yield the 18 to 19 millimeter string height. And I've clarified this in numerous past videos, and I apologize if I've already repeated it or mentioned it, but if you're not going with a pick guard, then you might want to leave your pitch 2.5 degrees, because otherwise you'll have to change all your jigs. But just if that's the case, you might allow this neck to just drop down into the body just about a 64th of an inch, because it's exponential what starts taking place if you're not careful. Okay? So I refuse to do this video again. I'm just going to keep talking and hopefully it will work out. And then I won't drop the guitar off the table or anything tragic. And what I'm going to do is pause and okay, we talked about the taper. I'm gonna pause and I'm gonna crank up the router station over here, and we're gonna turn this into a profiled neck in real time, uh, or at least in paused time. The only thing I didn't clarify probably was that based on all the dimensions that Ed gave me, or I should say the client gives you on the front end, you always have these dimensions in mind. If they give you, certain thickness here, which is awesome. If you have it, then you're building everything up to that point in component form, so that once you get here at the end, you're really just kind of machining off a pre-engineered taper, which I don't know if you can see that, but see, it's already tapered. It's thinner down here than it is up here. But what is it based on? Well, it's based on the dimensions that the client gave me, based on a guitar that he has in the house that he's had since he was fairly young. So he's really accustomed to that guitar, and that was our muse. So if that's our muse, it's my job to take his calculations, and if he tells me, yeah, I like more of a round soft C rather than like a flat soft D, then I know to use the 7/8 inch radius. Sorry about that. I know to use the 7/8 inch radius bit for a little bit softer C than the 1 inch radius for the flatter D or soft D. So with that said, it was awesome for him to mic a guitar that he has, and just basically made my job a heck of a lot easier. I would have been able to, but what is kind of funny, the dimensions he gave me, the nut width is 43.53, and what do I typically build my guitars at? 1 in 23/32 inch. And what is that? The difference is there's not, they're identical. And then at my first fret location, he gave me a thickness of 21.85 millimeter, and I always build mine at, like my general guitar, at 22 millimeter. And what is that? It's exactly 7/8 of an inch. And then at the 11th fret, he gave me the dimension of 24.23, and that's 31/32 of an inch, which is just a 32nd of an inch under 1 inch, or right at about a 25 millimeter. So, and what do I build my next? 25 millimeter. So I say all that to say this. I think I probably could have built this neck without even ever having spoken to the client, and he probably would have liked it. Other than he probably would have said, "Oh, everything was fine right at the point where you put that soft D on there. I wish you could have put the C." So it was cool to be able to communicate with the client on the very, very front end, and him give me very concrete uh, um, details and information. So with that said, Ed, I really think this is going to be the guitar that you want. I don't think we're going to miss it at all. I might miss it by a microscopic amount, but I don't think you'll be able to feel it at all. Okay, and it should feel a little bit different than Eric's S69 SG that I built, because this is the bit that I used to build Eric's 69. I'm so sorry about that. I know that was loud as hell. This is the bit that I used to build Eric's 69 SG neck. But then when I restored Eric's 81 Explorer, sure enough, I mic'd it, and this is the neck that it had on, the profile that it had on. But where I, and it wasn't a mistake or anything, but your 81 Les Paul here, this is a Gibson 81 Les Paul Custom. It has the 1 inch radius, okay? And I apologize if that's a repeat of something I might have spoken about in the beginning of the video, because I know in one of the videos that I erased, I spent way too much time talking about that crap. Okay, so let me just stop talking and let me see what I can get off the table so I don't repeat it. That's about to turn into a cranked up router. And then what I'll do, like I did in video 5, I'll pause and come back and I'll show you as it's materializing. And apologies again if this is being repetitive, but that's just your bearing guide block that guarantees that I don't round off the corner of the heel. Okay, so pretty sure that I've already covered that. So Okay, so we talked about that height there. What this is my clamping caul that I use. See, it has a radius to it, 12-inch radius, so that if this is the finished neck, I'm getting ready to glue that fretboard down. I drive a pin, or I put a pin at the first fret location, a pin at the 18th fret location, and the pin sticks through, and then it just hides down there, and it guarantees that when I do my clamping, because I like to put the fretboard on with Titebond. This is what I meant, and I think I talked about this in video 5. When I don't use quick grips, but I use C-clamps. But basically, once it's all going together, there's more than just this right here going on, of course, but that caul guarantees that I have perfectly, beautifully distributed clamping force with C-clamps, not quick grips, because I put some pressure on this when I'm gluing a fretboard down, and see, those pins guarantee that the fretboard doesn't slip on you, and you're not sitting there fighting it, trying to keep it in line. The pins guarantee that it goes exactly in location where it's supposed to go, and that's exactly how all the big boys do it as well. Okay, so by having that little caul there, that's what I meant by taking that caul, flipping it over, sliding it forward, calculating 5/16. Now I've got another tool that helps me guarantee that I'm building good guitars. Okay. All right, let me pause. Okay, it's been about 10 or 15 minutes, probably 20 minutes worth of work. Just set up and getting a feel for the routing station. I'm actually doing this with my drill press. I know that sounds really strange, but I call it like my overhead routing station. But I'm changing gears and I'm using a different jig, and I think I'm running it. Yeah, I'm running it at 4,600 RPMs, which really is a little bit too slow. But when I first made the very first cut, when I took off the corner, it was chipping out pretty bad and kind of spooking me. So if anything, and because of this curvature here, well, it's a stop point. It hits the deck and it forces a stop at a certain location, but that won't be the case when I'm routing this side, because when I'm routing across this one, I won't have a stop point down here, so I'll have to visually keep a real close eye. But if the bit, where I'm going with this is avoiding that kind of crap right there. So the last thing we want to do is have tear out in this location. That's probably almost a lost neck if that kind of crap happens. So this is where you've got to really study the orientation of the wood, the grain, and the direction of the bit. I'm not dare doing any climbing cuts on this crap at all. I'm doing all very controlled textbook push cuts or cutting cuts. But when I start coming around this corner here, I got to be extremely careful, because I'm cutting into the end grain. So I'm going to be taking my sweet time easing that corner off there. It's not too bad here because I'm cutting across the grain here. It's turning, whether it's overhead or on the table, it's irrelevant. The bit is always turning in this direction, whether it's here or there, because of the motor. The motor turns clockwise viewed from the top, or the bit turns clockwise. So I'm not worried about any tear out up here at all. But if I were to try to do some cutting up into here, you run the risk of a tear out up here, which you won't. But if you're going to have any sort of issue very unlikely you're going to have tear out issue right here, but there's a very strong possibility if you were taking off a massive amount at once and you're doing a pushing cut across that, there's a very strong possibility you could blow out that corner. So according to how what happens once I flip onto the other side and I'm doing this route work over here, uh, I'm definitely going to be studying that one, and I might do a climbing cut just to start it, but we'll see when we get there. So anyway, so back to machine work, and I'm going to go ahead and cut a considerable amount off, so that I'll probably do two more pauses, and by the third or fourth pause max, that line should be getting very close, or in other words, this radius will be getting extremely close to this edge right here, so much so that we're actually getting the benefit of using the machine tool in order to do the bulk of the job for us. And it's kind of cool how you can already see all that flat right there. However, it's beginning to look a little bit familiar. Okay, not that that's our target, but if you because it is not our target, but if you stopped at a certain location out here, then it leaves more flat in. Okay, so let me pause and be back in about 1/2 of a second, and we'll have a lot more work accomplished. Okay, didn't realize you could pause that long. It's probably been about 20 minutes or so. I've done about probably about seven passes. I've been going in very shallow increments because I'm running the RPM so low at 4,600. That's extremely slow, but it's cutting really well and it's really beautiful. And the most important thing about doing a job like this when you're relying on tools is, don't cannot lose that taper. You can't lose that platform. You've got to maintain that platform, and the way you can verify it is you come up in here with your pencil, and wherever it's flat, you make, this is before you do your machine work, or as you're doing your machine work and you start getting down to the point where you have to start monitoring what's going on, and I'll explain in a minute how you can make this in two different adjustments, but you just keep some pencil marks up here on the flat, and then as you're machining, as you begin to see the pencil marks disappear, well, then you're about to get dangerously close to the actual platform itself, and that's exactly what you want, because you're creating the actual 7/8 inch radius for your initial neck construction. I've never seen this before, meaning I've never seen anyone show this before or explain how you can do this. And I don't know if I would guarantee that it's going to work with every type of wood, but Honduran is so stable. You can do a lot of carve work right here, and the board not distort. And read between the lines when I make this statement. Um, as long as you're maintaining the center line of this neck, whatever the neck is doing, the bearing is going to follow that flat. Okay, meaning if you had a this is a crazy hypothetical, but if you had a template, you had a jig that had a little bit of a convex to it, or a concave. Convex would be better, but if you had a jig that just wasn't perfectly like NASA approved true, um, even if you clamp this atop that jig, and there's a little bit of a gap. There's not with my jig. My jig is perfectly S4S, but it doesn't really matter what's going on with the jig. You just want something to hold it down here and to hold it up here, and then allow the bearing to follow that line right there. In other words, you could have a jig that was just a block down here and a straight board all the way down, and then a block down here, and it wouldn't matter that it was floating here in the middle, even if the neck moved a little bit as you were machining it, please read between the lines. I'm not talking about doing shoddy work, but and it's not. My jig is one perfectly stable, but you don't have to glue this to something. Is where I'm going with this, and keep it perfectly true and not moving. Because if you've got a board that is so hypersensitive that it's going to start moving on you as you shape it, well then it's not a quality board to be working. That's why I love the Honduran. I can do like 98% of the actual profile on just one side, and then the neck is still perfectly true, down the flat. See, it didn't move, and you could go in and do the whole tile thing, the squareness, this, that, and the other. So that's an awesome feeling that, you know, and I'm not surprised, but there is no material left right here. In other words, you could not route anymore lest you would start losing the neck. So I've still got a little bit of a flat right here because this is where matters are going to get very, not probably not nearly as, no, it's not with this bit, but if you're working with this large 1 inch, the bearing actually, see, because you're under, once you go below 2 inches in the width here, and you're using a 1 inch radius, if you were using a 1 inch radius and you're trying to cut all the way to the very edge here, well, you can do that on one side, but then the bearing, there's not going to be a flat left down the middle like there is with this one. Since that's a 7/8 inch radius bit and this is a 1 3/4 inch wide nut, well then when I come up here and make this final pass up here, the bearing is literally going to be skirting right along the very edge of what little bit of flat is left right here, but it's only in this area right here. uh, However, that's and all the more reason to make certain that you don't try to machine this all the way down to like the finished thickness at the beginning, because in the event you made a mistake and went a little bit too low, what will happen is your bearing would now be dropping down to a point that is now lower or off the centerline flat. And what's that going to do? It'll create a notch. It would create a notch up to about that point right there. And then you might be sitting there. If that was your final thickness, it's not anymore because you're going to have to go thinner because you let it notch. But if you're already a millimeter thicker, too thick or over the target, then even if you wanted to get a little bit dangerous, and especially like if you're working with like the large, like when I build my custom necks for my guitars, I would be getting ready to change the bits and use this 1 inch bit, and I'd be running it pretty dangerously close where it's just barely skirting along that little bit of a, it would be off of the flat and beginning to get on the radius. But once I did all my final shape work, I'm blending everything together with flat blocking and making things disappear. And how does it feel? It already feels like a Gibson, man. It feels great. Or Gretsch feels like a penguin. Actually, this feels like a 57, 58 penguin replica that I have hanging behind me that I've actually been rebuilding the last few weeks. It's been really awesome. I'll probably will do a video series for that guitar. And what is the radius on it? The red bit. It's identical to this right here. So this feels like my penguin so far. Okay, cool. All right, so I'm really happy with that. And why sweat your ass off, scraping and sanding and beating and fighting that to the finish line when you can spend about an hour and a half setting up and using a bit. I mean, look at that. It actually looks like a finished neck, especially right in here. Then you'll have to blend the flat into the radius and whatnot, and that's where you'll actually still be shaping a neck. Oh, the most important thing is I need to clarify that's your target right there. That's a 50s. That's a mid 50s target for your flat. And what does that look like to me? Looks like a 59 Les Paul, man. because once and you want to leave that flat right there. You don't dare want to round in too much, and you even want to have some beautiful little flat left in right in this area. So that's what I meant by this is about as close to being the finished profile as you could get without pulling out your sanding tools. I don't know if I clarified the importance of, if you want to end with this being a certain dimension, well then make certain that you machine this first radius actually about 3/16 of an inch further. And you might look at that and think, man, that's going to be an enormous heel. No, actually, what you see right here, every bit of that's going to be gone. I'm going to be bringing it back to, well, that right there. And don't let this deceive you, because this is overhanging about 3/16 of an inch. It would be somewhere up in here in that area. Oh, that was pretty sloppy. But the actual heel uh, is going to be just like that once it's shaped out, or very close to that. Okay, so let me check the time. 50. It's only 50 minutes. Okay, let me pause and change gears, change the whole routing station up there, and I'm going to do some very gentle pole cutting or climb cutting over here, and let's ease our way to the finish line on the other profile. Okay, so I'll be right back. Okay, it's been probably 35 minutes, if not longer, because I really slowed down and thought through a few things. And I started to leave much more flat up here the way I did down here. But since I'm going to be taking close to over a 32nd of an inch, it's going to be coming off this whole side right here. So I went ahead and just I took it straight to the finish line. There's no more neck left, meaning platform. There's no more platform. So I radiused it all the way up to the actual finished neck platform, except for right here. You might be able to see that pencil. There's a little bit of pencil line right there. So what will happen? I could just go ahead and take off like a 64th of an inch right there, a little bit, flatten it out some to see what's going on. Because once the fretboard goes down, and this is the whole idea about building a guitar that has a jazz profile to it, meaning it rounds. You'll be rounding the lower into the binding, and then rolling the binding into the actual fretboard. And if it did not have binding, well, then you're just rolling the lower into the like rosewood. In other words, if it was a traditional Explorer without binding, then you would just be rolling the lower into the rosewood, and then rolling the top of the rosewood over up into the frets, and creating a real soft, sweet rolled. It's called a rolled fretboard, if that's not obvious by now. So that's what you want. You want to have just a little bit of flat left right there after it's all said and done. And see, once this gets sanded down and taken in about another, it's almost a 32nd of an inch that it will still be going in. It's amazing how quickly this little bit right here, which now is kind of rounding over, will all of a sudden become flat again. And it'll look a little bit closer to this. However, on this side right here, I was a little bit conservative, and I could have gone a little bit farther on this one, because see, I still have flat right there all the way up to right there. So the radius stops, in other words, it stays flat. It's hard to explain unless you've actually done this before. But all that flat with this one, what will happen here, you would not want to start coming over here and sanding down, because you need this platform right here. I very much need that neck right there. I mean, that material. I mean, I could miss it by a 64th of an inch and make things disappear with the binding and the roll. but nonetheless, that's the actual finished neck and guitar as well, where it goes into the body. Well, we actually have a body over here. Let's just let's look at it and see what it looks like. Before I forget, this is really important because that's obvious. Okay, the very cool thing about it is after relieving that material right there, it did draw down just a little bit. So let's put it in the neutral position and let's assess. Let's assess how much it might have relieved. I'll do the best I can to show that. There it is. There's our 32nd of an inch. So it relieved back a 32nd of an inch in its natural, and you can even see the way the straight edge is floating. It's not dragging. So that's awesome. And what does that mean? That's healthy. That's what it's supposed to do. When you machine material off of one side of a board, it wants to draw in that fashion. So is that problematic? Absolutely not. 100% not. But look at the beauty of having the forward adjustable truss rod. We're neutral right now. Put a little bit of forward push in it, and I'm looking down it. She is arrow straight without doing any sort of leveling. All I had to do was put just a little bit of forward push in it to let me make sure I'm not cheating. I feel it torque, and see that rod is really hypersensitive. Let me look at it first. Perfect. I'm not seeing any daylight when I look at it from the side, and I'll do everything I can to see. If I had a light behind the straight edge, you would be able to see, but let me get this so it's balanced. See how beautiful that is, how nice and flat that is. It's kind of hard to do. Let me just slow down. I think I went a little bit too much because I got a little bit of a forward bow right there. So isn't that amazing? Didn't even need that much. Just kissed it and there it is. Perfectly. No, it's relieving a little bit. So but when you get this close, that's considered really. I got a little bit of relief right there. And if it was problematic, well, then you just machine some of the top. No, that's it. That's close enough. Close enough for perfection. Okay. Very nice. Very nice indeed. I hope that's showing up okay. It's hard to hold it perfectly perpendicular. There, that's really beautiful. Okay. If you can't see daylight through it, then that's actually close enough right there. You could clean that with acetone and glue that down. It's a finished. It would be a finished guitar. And there's our 19th fret. I love having this fretboard to show that you can see it turns into like a 58 profile the way I cut them. See, that doesn't look like the modern design that I showed much earlier in the video, which was probably like 3 minutes ago, even though it feels like it's been an hour and a half. So there you have it. Looks like a Gibson, feels like a Gibson. And, oops, I'm off my mark. And if you were wanting to, what's the difference? What's the difference between this and a Penguin? A 56 Gretsch Penguin replica? Not much. Just a different headstock because it would have the square inlays. So you see my reasoning behind this. We're just building guitars basically. And when it comes to like profiles and stuff like that, well, that's just based on a certain radius and a certain feel. All right, I'm digressing, but it looks like the camera's probably not going to cut me off. And I'm gonna leave that block on there just for a moment, then we're gonna pull the block off here in a minute. As I think I clarified earlier in the video, probably like 5 or 10 minutes ago, see, I'm perfectly flush right now, but that is not the guitar. Based on this center, oh man, based on this center line right here, the center line of the body, and the fact that it's perfectly true, the neck and the body is too wide by about a 64th of an inch, if no, a 32nd of an inch, if not slightly more, intentionally. As I said earlier, I don't want, you don't want to machine these bodies perfectly finished, because then you don't have anything to sand off. But even if you had if you left a 16th of an inch on both sides, that's still very close to your finish line. And the fact that I cut them this close is primarily for binding. Because see, once I get up here, gosh, I'm not careful, it's going to turn into a super long video. But it's some good information. All right, let's just talk about fretboard, trapezoidal path, and such. As long as I'm not too wide right here, I could go ahead and do the binding. But if you weren't careful, if you had like a multi-ply binding, it would get you in trouble because it would distort the binding. It would not be going under it, under the fretboard in the appropriate location. So what will happen, I'll go ahead and truly define that. Now the fact that I have defined the center line with the body and the neck, etc., I will go ahead and machine this down a little bit, at least on the body, so that when I then cut for my binding channel will actually cut up into the body the same distance up under the fretboard that you never even see as it would cut out here. Okay, if I just did the binding channel right now, I would be a little bit too far away from the center line. That ought to make perfect sense. But that's what I meant. If you had this too wide and then you started routing for your binding, well, it's going to be wrong. And that's very important for the binding to be really beautiful and flow true, especially even though it's hidden under that fretboard. The way it exits out from under the fretboard is very important. Okay. So I don't even know. I don't think I showed it. I think I got distracted talking about that widths and stuff. But nonetheless, very, very true, very, very clean. And I love getting them this close to the finish before you do the actual glue-in work, because, man, that makes it so much sweeter when you're finishing the guitar. And also, it tests your ability as a woodworker. Really, when you really push yourself to the limit right there. See, I'll be taking a little bit more off of that in order to get that flat to sweeten up a little bit. Right now, it's a little bit too much flat right now. This is hard to hold. I hope that's showing up okay. Sorry, I spent too much time ends up becoming like a double-sided tape and the way I did that, I think I did that on camera, but I put that down, put some jet glue, and put tape on the other side, glued them together. I'm almost certain I did that on the front of the video. But see, that's not the heel. And you might look at that and go, oh man, that's way too much heel. Well, you had to have that mask, that distance there in order to get you started. Oh yeah, I'm glad I'm looking at this. Okay, Ed, here's something you need to consider. That's not the heel. The heel is basically going to be, let me see if I can draw it very quickly. I can feel myself trying to rush myself because I feel like, the video is about to end. No, actually, that's not it. Let me stop. But just take an image of this flat right here. That's my typical finished heel right there. This one's a little, see, you can see how this body's a little bit wider. That's actually often a finished guitar. So we've got the option, Ed, to flush the back of the heel with the body, blend everything in. I've got a really beautiful join right here. There's nothing that I'm trying to hide or that we need to hide, but another option would be to step it about 3/16 of an inch and then do the heel up here. I'll draw this, but just I'm almost hesitant to do this because this is not really the true heel. But in a minute, if anything, well, it can't really hurt because right now the heel is so freaking big, but you had to start with something. As I clarified, because the router bit, the radius is so freaking big, if I didn't start out with that mass right there, then the bearing would allow that bit to cut off the whole corner of each side. There wouldn't be anything left. But I could flush it out like that, but the only drawback to flushing out with this body is, and this is really overthinking it, but that's just the way I am. The grain, let me get this together as best I can. The grain on this body is it would have been so incredible if it had finally gotten to this point right here and then straightened out, but it didn't. It got really close to straightening out up here, but not down here. It's still pointing down a little bit, whereas this being a quarter sewn neck, this grain right here is incredibly straight. So I'm going to do the best I can to see if I can get that to pick up, and you can see the transition, which that would probably bother me a little bit if we were to try to flush out the heel with the back. I would kind of prefer to do a stepped heel, and if you don't know what I'm talking about, we did it in Eric's 81. I've done it in a lot of the other guitars that I build. And I got to tell you, it's really tasteful. It's really beautiful. But in 1958, neither one of these options would have been what they would have used. In 1958, it was really unfinished. It was not a refined job. They allowed the bottom part of the body to project out, about another 3/8 of an inch or so, because it was fairly thick. And then there was this really unsightly joint, about in that location right there. And I don't know what the hell they were thinking, but they were doing the best they could, because like I said, Leo Fender was in their hair so bad they were trying to figure out how to recoup from what he was manufacturing and delivering. And I think they were attempting to do some sort of possible bolt-on configuration. And I think there at the last, they probably just said, oh, the hell with it, just glue the thing in. But there was this very unsightly glue line. But what I've got built right here, this is per like jazz standards, where the neck is truly machined to the body. But we could also, let me see if I can get lucky and show it stepped. I could, not that far. This is hard to do with one hand. Damn, I can't hit it. I keep getting off. Probably be about right there. Let me get that pencil out. That's getting real close to where it would be. That would be like a stepped heel configuration. And then what would happen is the radius right here would continue across this point right here. It's really beautiful. It's very tasteful. And that's exactly how they did the 76 limited edition. When they reintroduced this guitar, they stepped the heel out. Hell, I should have been doing that right there. And that's kind of what it would look like right there. Except it wouldn't have this mass out here. It would be that pencil line back there. I have too much crap on the table. Okay, so the next thing, and I'm sitting here looking at it on the table. If this were my guitar, it's a given. I love that. That's definitely the route I would go. Again, if this grain had have straightened out, probably would have definitely been a candidate to consider a flushed heel, which would look a little bit more like that right there. Is either one of them a mistake? Absolutely not, because the machine work is so pretty. Uh, and even in, I reserve the right to change my mind. Let's put it that way, because this is very difficult to pull off, and it shows my ability as a builder to do just that, to do really good joinery. So I'll keep you posted on that, but just tell me what you think as well. But what would have been closer to 58? This right here, flushed out on the back. But it's kind of driving me crazy because of the grain. And anyway, I'm overthinking it right now. But I think that's good rather than just going, oh yeah, let's just cut it off and then going over there to the table saw and clipping that off, only to realize that you could have, and ended up with this right here. And it's okay. It's really pretty. But this right here is how, I'm just going to stop. Most like pro guitar builders would be shooting for that target right there. But I'm going to stop because if I continue, I'm just repeating what I just said. Okay. And I hope that was in the camera. 1 hour, 11 minutes. Give or take. I'll have to show it in this position. Yeah, that's a fairly good view as well. This is primarily just for Ed to see. That's a very, very shallow step. Probably not quite deep enough, but and see, that would be getting too much right there. That's probably where it would be. If we were going to step, no, probably not that much. Okay, all right. What else do I need to talk about? Okay, we talked about the fretboard finish. Right now, this neck is 1 3/4 inch wide. It's going to be machined down a little bit to flow in, and then I'll be doing the traditional trickery where you kind of come off that center right there with a flat, and then you roll out pretty fast. You curve right there, leave a little bit of a flat right there, transition into that. And all this right here gets shaved off with rasps and chisels. And then what happens right here is a really beautiful, right from under the nut, just a really sweet, beautiful, soft transition. Look at that. I hit it spot on. And then it rounds a little. It rounds a little bit right here. You'll see it probably in the next video, for certain in the next video, because that's actually what would happen next. And then it has just a little bit of just the way you see this hump down right there, the way it humps down and rounds over, you would try to keep that as much as you can, even though you're moving it up by hand. See, you couldn't machine, if you tried to machine further up, what would happen, the router, see, you can see where the router bit was about to get ready to start doing some irrecoverable damage right there. If you go much further, it would cut out an excessive amount right here, and worse, if you go beyond that line, you'd start losing the neck, and that would be a very difficult area to repair. But all this will get removed and shaped. Why? For visual? Yeah, somewhat, but mostly for your hand to go up in there as you're doing additional work. And since you know how to play guitar, you know exactly what I'm talking about. All right, guys, I appreciate you dropping in. I can't think of anything else to talk about with respect to this. other than, yeah, since you're here, what will happen next? This is going to go on a straight line jig that I use for everything. And I literally will be using my Stewmac template starting out with 120. And in this jig, it cradles it up. The jig is it's basically like a 2x10. It's real tall, and it allows this to remain exposed. And then I will literally just be blending. I'll be blending this flat center, which I'm trying to maintain until I don't need it anymore. I'll be blending and rounding, blending and rounding, blending and rounding, and coming in here with I'm so tired I can't think what they're called. Whatever this is called. Whatever that's called. Be coming in like this right here and working every bit of that down after I come in first with my not that rasp. Well, just humor me here. Oh, I think it is this one. Hiding back there in the corner. This is going to finish the neck right there, that one little rasp. Every bit of this material will be cut off by hand up to a target point that I define later on. It won't be quite that fat. It'll be a little bit less than that. But I definitely want to maintain a real beautiful flat radius, actually a very tight radius out here, very round and true. And then don't lose the flat, but blend it into the neck. Same thing back here. I'll be doing a lot of the radius side. We'll be doing a lot of shaping and blending, shaping and blending, shaping and blending, yet staying away from lines like this. I'm kind of just talking out loud so you guys that are actually considering building can hear my thought process. Okay, that's always the trickiest part because I'm not left-handed. Since I'm right-handed, this is a breeze to do this one. And this one's hard to do because you're having to do it like this or either like this, and it's wrong. You really, as a player, I found it's best to kind of to shape like this. That's a difficult side to do unless you're probably left-handed, then that would be a breeze. Okay, so a lot of information there, and she's coming together very quickly. Really beautiful, beautiful job. And going once, going twice. Talked about that enough. Talk about overlays and stuff later on, but very quickly turning into a guitar. Okay, thanks guys, I appreciate you dropping in, and we'll see you in the next video. Thanks.